The journey of pineapple processing begins far from machines and factory walls, rooted deeply in tropical farmland where climate, soil, and time work together to shape the fruit's quality. Pineapple cultivation is a slow and carefully managed agricultural process that demands patience and precision from farmers. Unlike fruits that grow on trees, pineapples grow close to the ground on strong, spiky plants, each producing only a single fruit during its long growing cycle. From the very first stage, farmers must prepare the land thoroughly, loosening the soil to allow proper drainage and enriching it with nutrients that support steady growth. The spacing between plants is calculated carefully so that each plant receives enough sunlight, airflow, and nutrients, preventing disease and uneven development. Once planted, pineapple crops require constant monitoring over many months. Farmers manage weeds that compete for nutrients, control pests that can damage leaves or fruit, and carefully regulate irrigation to avoid water stress or root rot. The tropical climate plays a crucial role, as consistent warmth and rainfall help the plant develop strong leaves and a healthy fruit core. Throughout the growing period, farmers observe subtle changes in plant color and structure, using experience rather than machines to judge plant health. This stage determines the sugar levels, acidity, and aroma that will later define the pineapple's flavor, making agricultural decisions critical to the final product quality. As the pineapple plant matures, the fruit begins to emerge from the center, slowly increasing in size and weight over several weeks. During this time, the fruit transitions from deep green to a lighter green shade, eventually developing golden tones as sugar content rises. Farmers inspect the fruit regularly, checking firmness, color consistency, and size. Harvest timing is one of the most important decisions in the entire process. Pineapples do not ripen significantly after being harvested, so picking them too early results in bland flavor, while harvesting too late can lead to overripe fruit that spoils quickly. For pineapples destined for processing plants, harvesting usually occurs at peak ripeness to ensure maximum sweetness and juice yield. Harvesting is predominantly done by hand to protect the fruit from bruising and mechanical damage. Workers move through the fields with sharp knives, cutting each pineapple carefully from the plant while leaving a short stem attached. This manual approach allows workers to assess each fruit individually, rejecting any that show signs of disease, cracks, or deformities. The harvested pineapples are placed gently into crates to avoid impact damage, maintaining the integrity of the fruit's flesh. This hands-on process highlights the importance of human skill in an otherwise industrial supply chain, ensuring that only high-quality fruit proceeds further. After harvesting, speed becomes essential. Pineapples are living produce, and once separated from the plant, natural degradation begins. To preserve freshness, the fruit is quickly transported from the fields to nearby collection points. From there, they are loaded onto trucks designed to minimize heat exposure, often with ventilation or temperature control. These transportation steps are carefully planned to reduce travel time, as delays can affect texture, flavor, and safety. During transport, the pineapples are arranged to prevent crushing, ensuring uniform quality upon arrival at the processing facility. Throughout this early stage, quality control begins long before the fruit reaches the factory. Farmers and field supervisors maintain detailed records of planting dates, fertilizer use, and harvest timing. This traceability allows processors to track fruit batches back to specific farms, ensuring accountability and consistent standards. The relationship between farmers and processing plants is closely coordinated, as factories depend on a steady supply of ripe pineapples while farmers rely on predictable demand. This coordination ensures that harvest schedules align with factory capacity, preventing waste and shortages. Environmental conditions also influence farming practices. Sustainable pineapple farming increasingly focuses on soil conservation, responsible water use, and reduced chemical inputs. Many farms now integrate organic fertilizers and natural pest control methods to protect ecosystems while maintaining yield. These practices not only benefit the environment, but also enhance fruit quality, resulting in cleaner, healthier pineapples entering the processing chain. The emphasis on sustainability reflects growing consumer demand for responsibly sourced food products and long-term agricultural viability. The physical appearance of pineapples at harvest is a direct reflection of the care invested throughout the growing cycle. Uniform size, balanced sugar levels, and firm texture are indicators of successful farming practices. These attributes are essential for industrial processing, where machines rely on consistency to operate efficiently. Irregular fruit sizes or inconsistent ripeness can disrupt automated systems, increasing waste and reducing output. For this reason, farmers play a foundational role in the efficiency of the entire processing operation, even though their work happens far from the factory floor. As harvested pineapples leave the fields, they carry with them the results of months of labor, environmental conditions, and agricultural expertise. Each fruit represents a balance between nature and human intervention, shaped by climate, soil, and careful decision-making. The transition from farm to factory marks a shift from natural growth to industrial transformation, but the quality of everything that follows depends entirely on these early stages, where timing, handling, and agricultural precision quietly determine the success of the entire pineapple processing journey. Once pineapples arrive at the modern processing plant, they enter a highly controlled environment where precision, hygiene, and technology guide every movement. The transition from open farmland to an enclosed industrial space marks a crucial shift in the fruit's journey, as natural variability is transformed into standardized, high-quality food products. From the very first moment inside the facility, strict quality and safety protocols are enforced to protect both the product and the consumer. The pineapples are unloaded carefully and guided toward receiving stations where trained personnel conduct initial inspections, visually examining each fruit for ripeness, size uniformity, and signs of damage that may have occurred during transport. At the receiving stage, conveyor systems take over, moving pineapples smoothly through the plant at a controlled pace. Advanced processing facilities rely on stainless steel equipment designed for easy cleaning and durability, creating an environment that minimizes contamination risks. Workers wear protective clothing, including gloves, hair coverings, and masks, reinforcing the plant's hygiene standards. These measures are not optional but essential, as even minor contamination can compromise entire production batches. Every surface that comes into contact with the fruit is sanitized regularly, and cleaning schedules are integrated into daily operations. The washing process represents one of the most critical stages inside the plant. Pineapples arrive with traces of soil, dust, insects, and natural residues that must be removed completely. High-pressure water jets and rotating brushes work together to clean the fruit thoroughly without damaging its tough outer skin. The water used in this process is often treated and recycled, balancing sanitation requirements with environmental responsibility. The washing stage ensures that only clean, safe fruit moves forward, setting the foundation for all subsequent processing steps. Following washing, the pineapples enter automated trimming and preparation lines where precision machinery performs tasks once done entirely by hand. The leafy crowns are removed using sharp, high-speed blades that cut cleanly and efficiently. These crowns are collected separately, reflecting the industry's growing focus on waste reduction and byproduct utilization. Peeling machines then strip away the rough outer skin with remarkable accuracy, exposing the golden flesh beneath while minimizing unnecessary loss. Sensors and adjustable cutting systems allow these machines to adapt to slight variations in fruit size, maintaining consistency across thousands of pineapples per hour. Even with advanced automation, human oversight remains essential. Workers positioned along the conveyor lines inspect peeled pineapples, trimming away remaining imperfections and ensuring the fruit meets strict visual and quality standards. This combination of machine efficiency and human judgment helps maintain a balance between speed and quality, preventing defects from advancing further into the process. The presence of skilled workers also allows immediate adjustments if equipment performance shifts or irregular fruit appears. Coring follows as another key step in standardization. The pineapple core is dense and fibrous, unsuitable for most consumer products, so it must be removed cleanly and consistently. Coring machines drive cylindrical blades through the center of each fruit with precise alignment, extracting the core in seconds. The removed cores are not wasted, as they are often redirected to juice production or other secondary processing lines. This approach maximizes yield while supporting sustainable practices within the plant. Once prepared, the pineapples move into cutting and shaping stages where they are transformed into recognizable product forms. High-speed slicing machines create uniform rings, chunks, or spears depending on the intended final product. The accuracy of these machines is essential, as uniform size ensures even processing during later stages such as heating, freezing, or drying. Cameras and digital controls monitor cutting patterns in real time, making adjustments automatically to maintain consistency. This level of precision is a defining feature of modern food processing technology. Throughout these operations, quality control checkpoints are embedded directly into the production line. Samples are taken at regular intervals to measure factors such as sugar content, acidity, texture, and color. Automated inspection systems, including optical scanners and metal detectors, add additional layers of safety. These systems can identify foreign objects, irregular shapes, or defects that the human eye might miss, allowing problematic items to be removed instantly without stopping production. Temperature and timing are carefully managed as the fruit progresses through the plant. Controlled environments prevent premature fermentation or spoilage, while synchronized conveyor speeds ensure that each pineapple receives consistent treatment. The coordination required to manage thousands of fruits simultaneously highlights the complexity of modern processing operations, where every second in movement is planned for efficiency. The plant itself functions as an interconnected system, with each stage dependent on the accuracy of the previous one. Any deviation in washing, peeling, or cutting can impact downstream processes, making continuous monitoring essential. Supervisors and technicians track performance data in real time, using digital dashboards to detect issues before they escalate. This integration of data and machinery represents the technological backbone of modern pineapple processing. Beyond efficiency and safety, the processing plant is designed to preserve the natural qualities of the pineapple. Gentle handling, sharp blades, and precise control help retain flavor, color, and texture, ensuring the final products reflect the fruit's original freshness. The goal is not simply to process large volumes, but to do so while respecting the integrity of the raw ingredient. By the time pineapples exit this stage of processing, they are no longer raw agricultural products, but carefully prepared components ready for further transformation. The controlled environment of the factory has replaced the unpredictability of nature with consistency, precision, and reliability, setting the stage for the final steps that will turn fresh pineapple into globally distributed. At this stage, the fruit is converted into a variety of consumer-ready products, each requiring specialized techniques designed to extend shelf life while preserving flavor, texture, and nutritional value. The diversity of pineapple products reflects both global consumer demand and the adaptability of modern food processing technology, allowing a single fruit to serve multiple markets through carefully controlled methods. For pineapple destined for canning, the process begins with precise handling of the cut fruit. Rings, chunks, and tidbits are guided into blanching systems where they are briefly exposed to heat through steam or hot water. This step plays a vital role in stabilizing the fruit by deactivating enzymes that could cause discoloration or texture changes over time. Blanching also reduces microbial presence, enhancing food safety without significantly altering the pineapple's natural taste. Timing and temperature are carefully regulated to prevent overcooking, as maintaining firmness and color is essential for visual appeal and consumer satisfaction. Following blanching, the pineapple pieces are rapidly cooled to stop the heating process. They are then transferred to filling stations where automated systems place measured portions into sterilized cans. Precision is critical at this point, as uniform filling ensures consistency across thousands of units. Syrup or natural pineapple juice is added depending on product specifications, with sugar concentration adjusted to meet different market preferences. The liquid not only enhances flavor, but also helps preserve the fruit during storage. Each can is sealed under airtight conditions, creating a protective barrier against contamination. The sealed cans proceed to thermal sterilization units, commonly known as retorts. Inside these chambers, cans are exposed to high temperatures for a specified duration to eliminate harmful microorganisms. This process ensures long shelf life without the need for artificial preservatives. Advanced monitoring systems track temperature, pressure, and time, ensuring every batch meets strict safety standards. Once sterilization is complete, the cans are cooled, dried, and prepared for labeling, marking the transformation of fresh pineapple into a stable, shelf-ready product. In parallel, pineapple juice production follows its own specialized pathway. Trimmings, cores, and selected fruit pieces are crushed to release juice, which is then filtered to remove fibers and solids. The resulting liquid may be processed into clear or cloudy juice depending on product requirements. Pasteurization follows, gently heating the juice to destroy pathogens while preserving its fresh taste. Some juice is further concentrated through evaporation under reduced pressure, producing a condensed form that is easier to transport and store. This concentrate can later be reconstituted, allowing pineapple juice to reach distant markets efficiently. Frozen pineapple products represent another significant segment of production. Cut fruit is spread across conveyor belts and rapidly frozen using blast freezing technology. Rapid freezing minimizes ice crystal formation, helping preserve the pineapple's texture and flavor once thawed. The frozen pieces are then packaged in airtight bags and stored in temperature-controlled facilities, ready for distribution to retailers and food service providers. This method allows consumers to enjoy pineapple year-round with minimal quality loss. Dried pineapple processing offers yet another avenue for value creation. Slices or chunks are arranged in drying chambers where warm air gradually removes moisture. This reduction in water content inhibits microbial growth and significantly extends shelf life. Some facilities employ freeze-drying techniques, which preserve color, shape, and nutrients more effectively than conventional drying. The resulting products are lightweight, flavorful, and popular as snacks or ingredients in cereals and baked goods. Throughout these final processing stages, sustainability remains a central concern. Modern plants aim to utilize every part of the pineapple, reducing waste and maximizing resource efficiency. Peels, crowns, and residual pulp are repurposed into animal feed, organic fertilizers, or bioenergy. Water used during processing is treated and reused where possible, and energy-efficient systems reduce environmental impact. These practices reflect a broader shift toward environmentally responsible food production that balances industrial efficiency with ecological stewardship. Quality control continues to play a critical role as products near completion. Samples are tested for taste, texture, sugar levels, and microbial safety, ensuring compliance with international food standards. Automated inspection systems scan finished products for defects, while traceability systems link each batch back to its production data. This level of oversight ensures that consumers receive safe, consistent products regardless of where they are purchased. Once packaged and approved, pineapple products enter the global distribution network. Pallets of canned goods, frozen fruit, and juice are stored in warehouses before being transported by trucks, ships, or trains to markets around the world. Efficient logistics systems coordinate these movements, ensuring timely delivery while maintaining product integrity. From tropical farms to distant households, the processed pineapple becomes part of a complex supply chain that connects producers, processors, and consumers across continents. The completion of this journey highlights the integration of innovation, efficiency, and responsibility within modern pineapple processing. Each product reflects careful planning and technological precision, preserving the fruit's natural qualities while making it accessible to millions. The result is not just a convenient food item, but a testament to how agriculture, industry, and sustainability can work together to transform a simple tropical fruit into a globally enjoyed product.